Hello, algebraic reasoning. Today we're going to be going over how I would want you guys to solve FlipGrid type questions. I picked a couple of questions that are very similar to what you're going to have to present, and I want to show you how to go about solving these questions. So let's get started. So first one is we're going to factor out it's the square root of 96. So if you don't know what 96 breaks down into, then you know it's even because it ends in a 6. Remember, we said if it ends in a 0, 2, 4, 6, or 8, it means it's even. And even just means it's divisible by 2. So I'm going to divide through by 2. So 2 goes into 9. 4 times 8, subtract 16. 2 goes into 16 8 times. So I know that the square root of 96 breaks down to 2 times 48. Now, when I see 48, I know 48 is divisible by 4 because 4 goes into 4 one time and 4 goes into 8 two times. So that should be pretty straightforward. So this is going to become 2 times 4 times 12. Okay. Now, with the square root of 4, I know the square root of 4 is 2. So notice what I did here. I took the square root of 4 out because I instantly saw that breaks down to 2, and I left that on the outside. Now, does that mean I'm done? No. I can still break down this 12, and we know 12 is 4 times 3. So 12 breaks down to 4 times 3. And then I'm going to repeat. I'm going to put the square root of 4 on the outside, and then I'm left with 2 times 3 on the inside. And so the square root of 4 is 2, so now I'm left with 2 times 2. 2 times 3 on the inside, which is 6. So this becomes 4 square root of 6. By the way, when we talk about the inside, we're talking about what's called the radicand or the argument of the function, just to give you some vocabulary. You don't have to use that terminology, but if you'd like to, you can. And I've broken down to 4 square root 16. 4 square root 6. By the way, if you wanted to, you can also check this. If you square the number on the outside and multiply by the number on the inside, it should get you back to the original number, which it does. So there you have it, and that works. By the way, you could have also made this process a lot easier by just saying that this breaks down to the square root of 16 times 6, which breaks down to square root 16 times square root 6, which is 4 root 6. So if you saw that, you could jump straight there. If you don't see that, that's okay. You can just break it down like I did here. Okay? Either way, it works. Okay, next one. Square root of 175. So I'm not sure what the square root of 175 breaks down. I definitely know, though, because of quarters, that it breaks down to 25 times, well, let's think about this. 4 quarters makes $1, and 3 is 75 cents. So 4 and 3 becomes 7. So 7 quarters. Or I could think about it as $2 is 8 quarters, and then I lose 125 cents. So now I'm back to 7. Just different ways of thinking. Square root of 25 times square root of 7, and this becomes 5 square root of 7. As easy as that. All right, next one. Now, what you're seeing here to spice things up is we're putting a number in front of the square root, but it's still the same process. So again, I see 125, so I think quarters. So I know 4 quarters is $1, so 1 more is $1.25, which then becomes 9 times square root 25 times square root 5, which becomes 9 times 5 square root 5, which is 45 square root 5. Cool. All right, next one. So now, to make things even more interesting, we've thrown in a variable, but that's okay. What I'm going to do is I'm going to focus on the 512 first, and then I'll deal with the m cubed. So with the 512, I'm going to break it down. Now again, I know it's even, so I know I can divide through by 2. So I'm going to divide through by 2. 2 goes into 11 5 times. 2 goes into 12 6 times, so this becomes 2 times 256. Now, some of you may know what 256 breaks down to, but I'm going to assume that we don't, so we're going to just keep breaking it down. So I know 256 is divisible by 2. So 2 goes into 5. Sorry, mine is going too fast. 2 goes into 5 2 times. 2 goes into 16 8 times. Okay, so this breaks down to 2 times 2 times 128. Now, because I can pair these two together, they can go outside and play. Remember, we argued that the index, that's this number here, when it's not written, it's 2, which means if you can pair them in 2, they can go outside and play. That's also, by the way, why we can say right here that the square root of 4 is 2, because the square root of 4 is actually the square root of 2 times 2, and because they're paired, they can go outside as 1 in the form of 2. So that's something you can do as well. And by the way, if you want to, in your presentation, if you want to do what I just did there, which is backtrack to some other questions to kind of give further insight, you're more than welcome to. In any case, this is 2 times the square root of 128. And then I'm just going to keep breaking it down. Now, I see 128. This one, I'm going to actually, instead of dividing by 2, I'm going to divide by 4 because that is very apparent, right? I can easily see that 12 goes into 4 3 times because 4 times 3 is 12, and 4 goes into 8 2 times because 4 times 2 is 8. So hopefully that's clear, and we'll have 2 square root 4 times 32. Now again, this is just 2 square root 4 times 32, which in square root of 4 is 2, so this is 2 times square root 32, which is 4 square root 32. Let's see here. Cool. And then we're going to keep going. Now, I know 16 times 2 is 32, so now I'm going to rewrite this as 4 square root 16 times 2. And again, 16 is awesome because the square root of 16 is 4. So this is 4 times square root 2, which is 16 root 2. So remember earlier, when I was working this problem, I said some of you may see 256 and know what that breaks down to. The square root of 16 times 16 is 256. So I could have jumped straight there. Now, we're not done yet with this question because remember, we also have the square root of m cubed. So remember, the square root of m cubed breaks down to m times m times m. And feel free to use your own sense of humor as you do these problems as well. Hopefully it's a little better than mine. I also wanted to show you that the reason why I was showing you this, where you can pair, they go outside, is because that principle applies here with the m's. So because I have two m's, if you can pair, they go outside. So this means one pair goes outside as the m, and then you have an m. So this is now including m times the square root of m. You can now put it all together. We got 16m. So the ones on the outside go hang out together, 2m. And the ones on the inside go out and hang out together. Okay? All right, let's go on to the next one. So the last one is going to be, let's go light blue, square root 72x squared. So again, this is more of the same. We're going to play with the 72 first, and then we're going to play with the x squared. Now, I'm going to go a little fast here. 72 is square root 36 times 2. Sorry, 72 is 36 times 2, which is the square root of 36 times the square root of 2, which is 6 root 2. Now the cool thing here, again, remember, with this piece, x squared is x times x. Now, because I can pair them, they go outside, and there's nothing left inside, so we're just left with x. Put it all together, 6x square root 2. Okay, and I wanted to do one more. You only have 5, I did 6, because I wanted to show you that sometimes this can happen. So what I wanted to show you is this is a perfect square root, which is 10. Some of y'all, you're gonna see these sometimes. Square root of x squared is just x, and y to the 4th is y is going to leave you with y squared. Now, y to the 4th, let me do a little more here. This is, right, 4 y's. And I said if you can pair them, they can go outside and play. So you have 2 y's that can go outside and play, which is y times y, which is y squared. So the final answer, put it all together, 10x y squared. Okay, so sometimes it cleans up entirely. All right, so there you have it. That's what I'm going to be asking you guys to do. Just repeat something very similar and you'll be fine. So hopefully this makes sense. If you have any questions, please reach out to me, and good luck.